Right now, the sun is awake, and in the last few weeks it has done something that has space agencies around the world watching it every single hour. It has fired off flare after flare after flare, and at least one of them was aimed almost straight at us. We got lucky. The blast mostly missed, or arrived weak enough that the lights stayed on. But the scientists who study this will quietly tell you that luck is not a plan. Because the sun has now entered the most violent stretch of its cycle, and a single storm, just a little bigger than the ones we have already survived this month, could cross 93 million miles of empty space and switch off the modern world. Stay until the end, because the most unsettling part is not whether this will happen. It is that it already has. And the last time, we were not ready. We like to think of the sun as steady, constant, the one thing in the sky we can count on. But the sun is not calm. It is a churning ball of plasma wrapped in magnetic fields that twist, tangle, and snap. And roughly every 11 years, that magnetic activity builds to a peak, a period astronomers call solar maximum. During that peak, the sun is covered in dark, magnetically violent regions called sunspots, and from those regions, it launches two kinds of weapons. The first is the solar flare, a burst of radiation so intense it reaches Earth in about 8 minutes, traveling at the speed of light. The second is slower, heavier, and far more dangerous. A coronal mass ejection, a cloud of billions of tons of charged plasma hurled off the sun and out into space, sometimes straight toward us. And right now, we are sitting inside that peak. In just the past few weeks, the sun has thrown out some of the strongest flares we can measure, including an X-class flare, the highest category there is. One active region alone produced a chain of them in a single day. Space weather agencies issued storm warning after storm warning. Auroras lit up skies far from the poles, beautiful and harmless to look at. But that glow is the visible edge of something that, scaled up, is not harmless at all. Because here is what actually happens when a large coronal mass ejection reaches Earth. The cloud of plasma slams into our planet's magnetic field, and the whole field begins to shake. That shaking is what we call a geomagnetic storm. And a shifting magnetic field does something simple and dangerous. It induces electric currents in any long piece of metal sitting on the ground. Power lines, pipelines, the vast web of cables that carries electricity across entire continents. Suddenly, currents that were never supposed to be there start surging through the grid. And the grid is fragile in one very specific place: the transformers. These are the massive machines that step electricity up and down as it moves across a country. They are not designed for the kind of surge a major solar storm can push into them. Overload one, and it can overheat, melt, and die. And here is the part that should make you sit up. The largest of these transformers are custom built. They can take a year or more to replace, and almost no one keeps spares. Knock out enough of them at once, across a continent, and you are not looking at a blackout that lasts hours. You are looking at one that could last months. Now think about what runs on that grid. Not just your lights. Water treatment plants that pump clean water to cities. Refrigeration for food and medicine. Hospitals. Fuel pumps. The internet itself. The data centers, the routers, the cables under the ocean. A long enough blackout, over a large enough area, does not just turn off the lights. It quietly switches off the machinery that keeps a modern society alive. And it would happen almost everywhere at once. It sounds like a disaster movie, so let me tell you the part that is not fiction. It has already happened. In the year 1859, the sun launched one of the most powerful storms in recorded history. It is now called the Carrington Event. Back then, there was almost no electrical technology to damage, just the early telegraph network. But that was enough to show us what the sun can do. Telegraph lines sparked. Operators received electric shocks. Some machines kept transmitting even after their power was disconnected, running on the current the storm itself was pushing through the wires. Paper caught fire in telegraph offices. And in the sky, auroras blazed so brightly near the equator that people woke in the middle of the night believing it was morning. In 1859, that was a curiosity, a strange, beautiful night. Today, the exact same storm would hit a civilization that has wired itself together with billions of miles of vulnerable cable and built its entire existence on top of electricity. The same storm, a completely different world to land on. And before you tell yourself it could not happen again, it almost did. In 2012, the sun fired a coronal mass ejection just as powerful as the Carrington Event. It tore across our orbit at enormous speed. The only reason you never heard about it is timing. It crossed the exact spot where Earth had been just 9 days earlier. 9 days. If that storm had left the sun a little sooner, it would have hit us head-on. And the scientists who studied it afterward estimated the damage could have run into the trillions, with recovery taking years. We did not dodge it because we were protected. We dodged it because we happened to be somewhere else that week. And the smaller reminders keep coming. In recent years, powerful storms have already knocked satellites out of orbit, scrambled GPS and aviation routes, and forced grid operators into emergency corrections. Every one of them is a tap on the shoulder. A reminder that the sun does not care that we have built our entire world on a system it can reach out and break. So why are we not ready? Part of it is that the threat is invisible until the moment it arrives. A hurricane you can watch coming for days. A solar storm gives you, at best, a warning of a day or two from the moment a cloud leaves the sun, and only a rough guess at how hard it will hit until it is almost here. Part of it is cost. Hardening an entire continental power grid against something that might happen once in a century is a bill no one wants to pay. And part of it is simply that we have been lucky for so long that it has become easy to believe the luck is permanent. But we are at solar maximum now. This is the window. The flares of the past few weeks, the storm warnings, the auroras drifting down toward places that rarely see them, these are not random. They are the sun reminding us, gently, what it is capable of. And gently is the key word. Because everything we have weathered so far has been the sun holding back. So here is the truth that sits underneath all of this. The question was never whether the sun could cripple the modern world. We already know that it can. It did it in 1859, and it nearly did it again in 2012. The only real questions are when the next big one arrives, whether it is pointed at us when it does, and whether we have done anything to prepare before it gets here. And right now, the honest answer to that last question is not nearly enough. The sun has been quiet, as far as human history goes, for a very long time. But quiet is not the same as safe. And the next time you see the northern lights drift somewhere they are not supposed to be, remember what that glow actually is. The visible edge of a force that, on a bad day, could reach across 93 million miles and pull the plug on everything we have built. So I will leave you with this. If a storm like 1859 hit us next week, how long do you think it would take the world to recover? Days or years? Tell me in the comments. And if you want to be here when the sun makes its next move, because at solar maximum it will, you know what to do. Because the most dangerous thing about our star is not that it might one day turn on us. It is that it already has, and we keep forgetting.